Here is another example which relates linear relation and rate of change. So study the graph and answer the questions as we have been doing in these set of videos. So what you need to do here is interpret the given situation. The situation is given here in the graph, and it says a hot cup of tea is left on the table. Now if a hot cup of tea is left on the table, then what happens? It starts cooling down. So it's cooling of tea and shows what? So you need to define your variables and interpret this particular graph. It shows cooling of tea. So that means the hot cup of tea, which was at a high temperature, with time its temperature is falling down, right? And you can read the initial temperature from the graph. Now, after having a good look at the graph and understanding the situation, answer these questions. The questions are: define variables. What is rate of change? What does rate of change mean? What is initial value? What does initial value mean? What would the temperature be after 30 minutes? And what is the equation of the line? So once you've done all these questions, then you can look into my suggestions. Since we have already done a couple of similar questions asking same questions over and over again, I hope by now you are an expert. So you can stop the video and answer the questions, then look into my solution or suggestions. Here are my suggestions. First and foremost is always to have a close look at the graph and connect it with the situation. The situation here is a hot cup of tea is left on the table. So that is the situation. And cooling of tea, that means cooling of temperature of tea, is being shown on the graph. So you can see that the initial temperature is, as you can read from here, 90 degrees, right? 90. Now in this graph, we have not put anything on the scales on a purpose. I want you to put them, right? So it's good practice to write the scale here, and it gives an indication, but it's not very clear. So let's write down temperature here. And this temperature is in degrees Celsius. So that is the temperature, and the independent variable here is time. So let me write time here, and time could be in minutes, right? So now we can make a story and say, well, on the horizontal axis we have the independent variable time in minutes, and on the vertical axis we have the dependent variable temperature in degrees centigrade. So that is how you can define your variables, correct? Now cooling of tea is very evident from the graph. Temperature initially is 90 degrees Celsius and it drops every minute. In 20 minutes it drops down to 40 degrees Celsius. Now, what is the rate of change? To find rate of change, you need 2 points on your straight line. If it is a straight line, you know any 2 points on this line will give you exactly the same rate of change, right? As an exercise, you can test that also. Let's take these 2 points. Bigger the triangle, better the result, right? So we are considering the 2 points as marked. Now, first is the initial point. So in initial point, we have time 0 and temperature 90 degrees. So let me write 0, 90, right? I'm not writing degree Celsius here, just the numbers. And the final temperature shown here is time 20 and temperature 40. So those are the coordinates. To find rate of change, we need to do rise over run. So rise is negative because we are going down. Do you see that? We are going down. So we are going down from 90 to 40, and therefore rise will be 40 minus 90. And the run is from 0 to 40. So it will be 0 to 20. So it will be 20, this number, 20 minus 0. So we get minus 50 over 20. So that is what we get as rate of change. So it is 50 divided by 20 with a negative sign. So negative shows that the temperature is falling down, right? And 50 divided by 20 is 2.5. So 2.5 degrees Celsius per minute. That is the unit, right? So what does the rate of change mean here? Rate of change means that the temperature is falling at the rate of. So we say temperature falling, since it is negative, right, at the rate of 2.5 degrees Celsius per minute. So that is what it means, right? What is the initial value? Initial value is 90 degrees Celsius. What does initial value mean? It means that when the cup was left on the table, its temperature was 90 degrees Celsius, right? It was that hot. What would the temperature be after 30 minutes? So as we can see, every minute it falls by 2.5 degrees centigrade. So in 30 minutes it will fall by minus 2.5 because the temperature is decreasing times 30. So that is what will be the difference in temperature, right? So you can multiply this and you get times 30 will give us 75. So minus 75, correct? So that is 75 lesser than what? Lesser than initial temperature. So what was the initial temperature? 90 degrees, right? So after 30 minutes, the temperature will be 90 minus 75, which will give us how much temperature? If you take away this, you get 15 degrees, right? 15 degrees Celsius. We are assuming that we are letting the temperature fall at this rate uniformly forever, okay? Now, that is the temperature which we expect after 30 minutes if the cooling rate is constant, okay? Now, last question is, what is the equation of line? So the equation of the line, normally you write as y equals to mx plus b. But as I am specifying, we should write in terms of the defined variables, right? If you write x and y as defined variables, it is fine. But in case, as I was saying, if you write time as independent variable, if I define variable as time in minutes, and temperature, let's say capital T in degrees Celsius, right? If I define these as my variables, in that case, temperature is dependent on time, and my equation should be temperature is equals to, what is the rate of change? Minus 2.5. Minus 2.5, and the variable is T along horizontal axis, right? So my temperature is dependent on time plus the initial value of 90, right? So that becomes the equation of the graph shown here, right? So the line is represented by capital T equals to minus 2.5 small t plus 90, where capital T is in degrees Celsius and small t is in minutes, right? Now I have a question for you. Let me add this question here, right? The question here is, if the room temperature is 25 degrees Celsius, so let's assume, right? Let's assume You can see here that there is no restriction on the room temperature, right? Since we say it goes to 15 degrees, it cannot cool down cooler than the room temperature, of course, right? But this was just a mathematical model. Now let's assume that room temperature is, let's say, 25 degrees Celsius, right? Then figure out after how many minutes or when will the temperature of the teacup be same as room temperature, or in how much minutes will the temperature fall to 25 degrees Celsius. Okay, so that could be an exercise for you. I hope you understand and appreciate this example. Let's move on and do some more. Thank you and all the best.